What is an inverse trig function? Well, we've talked about inverse functions in this class. Now it's time to talk about inverse trig functions and how to evaluate or figure them out. A regular trig function, you plug in an angle and you get a trig value back. Well, naturally, if you wanted the inverse of that, you just flip these two. Okay, with an inverse trig function, you plug in the trig value and you get the angle back. Okay, pretty weird, but if we look at the unit circle, it's actually not that hard to comprehend. Let's look at that real quick. So here's basically how it works. Let's just start with degrees for now. Let's say we wanted to know where on the unit circle does sine equal 1/2. Well, that'd be the y value, right? Would be at 150 because the y value is 1/2 there. Second, right? And it would be 30 because the y value is 1/2. Nowhere on the unit circle does the y value equal 1/2, so that's only two angles where sine is equal to 1/2. So inverse sine of 1/2 would be both 150 and 30 degrees. In terms of radians, it'd be pi over 6 and 5 pi over 6. Again, there's two places where sine equals 1/2. So you can have more than one answer. So that's an inverse trig function in a nutshell. You give the value of the trig function. Your answer is at what angle does the trig function equal that? So that's why it's inverse. You're swapping your inputs and your outputs. Here's how we write inverse. I'm going to show you another way. For right now, it's sine to the -1. That's what it looks like, but it means inverse. So you'd be plugging in a ratio, like for the example we just did. Sine inverse of 1/2 would be equal to both 30 degrees and 150, or if you're in radians, pi over 6 and 5 pi over 6. Here's the normal trig function. You plug in an angle, sine of 30, you get 1/2. Plug in an angle, sine of 150, you get 1/2 back. So x represents a ratio on the unit circle. The other way to write this is arc sine, or arc whatever the trig function is. And I am not good at handwriting, especially when it comes to letters. Okay, but arc sine is the same thing as sine inverse. It just depends on who you talk to, which one they use. Now, we are going to be using these bottom three identities. These are called inverse trigonometric reciprocal identities. I'm going to show you the proof for one of them. If you're trying to evaluate the inverse of cosecant, secant, or cotangent, those points, those values don't really show up on the unit circle because they're not just strictly x or y. They're a combination of the two. See, it's easier to figure out inverse sine and cosine because you just figure out where on the unit circle it's true for the x value for cosine and y for sine. But for the other four trig functions, tangent, secant, cosecant, and cotangent, they don't show up as much. Now, tangent, you're going to have to learn the tangent unit circle, and I'm going to show you what that looks like. We've done this so much that it's time you learn these tangent values, and we've talked about this before. Tangent is equal to some variant of square root of 3 when it's closest to the y-axis, and some variant of square root of 3 over 3 when it's closest to the x. Tangent is positive in the first and third, negative in the second and fourth. Tangent is undefined on the top and bottom of the y-axis and equal to 0 on the sides of the x-axis. That's it. So if you know these values, okay, of tangent at each degree or radian, of course these have radians equivalents, pi over 6, pi over 4, so on and so forth, and you know the points on the unit circle in terms of radians, so x and y, then you know sine, cosine, and tangent at any given angle. So all you need to do is know these identities in order to figure out the reverse. Okay, so here are the identities going back here. If you want to figure out the inverse of the other three trig functions, you need to know these identities. So say you were going to figure out inverse cosecant of 2 radical 3 over 3. So 2 radical 3 over 3 would be your x value. Well, here's a quick identity that can help you figure that out. You would plug in 2 radical 3 over 3 in for x, simplify, and that would give you square root of 3 over 2. Now you can figure out sine inverse of square root of 3 over 2, because that's just sine is the y value in unit circles. And then you would go and say, okay, well, right here already, at 60 degrees, pi over 3, we have the y value of square root of 3 over 2. So cosecant inverse, 2 radical 3 over 3 would be 60, or pi over 3. It would also be true at 2 pi over 3, since that's also the y value of square root of 3 over 2. So you need to know these identities, these 3 down at the bottom. These 3 up here are also true, but we don't use them as much, simply because we already know that sine is y, cosine is x, and tangent is this special tangent unit circle I'll just show you. So you need to memorize this, okay, on top of the fact of knowing those identities. Okay, let's look at a proof for this first one. The other 2 proofs are similar. Cosecant inverse of x. Why does that equal sine inverse of 1 over x? Let's start with this, okay? So let's just say we want to figure out cosecant inverse of x. Say, like I said before, 2 radical 3 over 3. We don't know what the angle is. We learned before in trig that if you take the original function of the inverse, they cancel, and vice versa. Inverse of the original cancels. So we want to take the original cosecant function of both sides, and we'll cancel the inverse out. On the left, we'll just be left with x equals cosecant of theta. And that went up too much. Didn't want it to go that much. So where do we go from there? Okay, cosecant of theta is 1 over y, right? So let's do some rearranging here. Multiply both sides by y. Probably should have showed that step. Okay, y times x. Okay, so we'll have x times y. These y's will cancel, equals 1. Now, then we're going to just redivide both sides by x. Again, I should probably show that step. Now we have 1 over x equals y. Now y is just the sine of theta, right? Y value is just sine. We proved that with our coordinate identities. Sine of theta equals 1 over x. Now we're going to take the inverse of both sides, cancel out the sine, so we just left with theta. And we also have to take the inverse sine of the right side, so we get theta equals sine inverse of 1 over x, which is what we're trying to solve for to begin with. We said theta was equal to, let's go back to the top so we can remember. Remember, we have theta is equal to cosecant inverse of x, so we can replace theta at the bottom of our proof with cosecant inverse of x, and this proves that cosecant inverse of x is equal to sine inverse of 1 over x. Again, we can do the same thing for the other 2, but this puts it in perspective and helps us because we already know the y values in the unit circle, and therefore figuring out the inverse sine of 1 over whatever that ratio is will give us cosecant inverse. So let's go ahead and start out with one of those. Sine inverse of 1/2. Alright, so this one's actually easier because we don't need to know one of those identities. This interval is also important. Okay, it says for any angle between 0 and 2 pi, including 0 and 2 pi. So anything on the standard unit circle, where does sine equal 1/2? Well, fortunately, it's already in terms of sine. So step 1 says use inverse trig reciprocal identities to convert to sine, cosine, or tangent. Since it's already in sine, we can quickly just look at where the y values equal 1/2. So pulling back up our unit circle, where does y equal 1/2? Well, if you've studied enough, you'll know that y equals 1/2 at pi over 6 and 5 pi over 6, which means that sine is equal to 1/2 at pi over 6 and 5 pi over 6. So it just takes really knowing the unit circle. If it said negative 1/2, you would just jump down here to 7 pi over 6 and 11 pi over 6. So you really got to know your unit circle in order to master this lesson. Step 2, determine the coordinates on the unit circle associated with the given trig value. And those are the 2 points we just figured out. Alright, then you want to figure out what angle that is where those 2 points exist. And again, it's at pi over 6 and 5 pi over 6. So sine inverse of 1/2 is equal to these 2 angles. Remember, the answer for an inverse trig function is an angle, or sometimes two angles. That's your last step. Step 4, write out the answer. And that's it. Let's go on to another example. Cosecant inverse of -2 radical 3 over 3. So now we really need to use that inverse reciprocal identity. Furthermore, let's actually pay attention to the interval. We're only worried about angles between 270 and 360. All right, so that's the fourth quadrant. All right. In other words, somewhere down here between 270 and 360. All right. Now, we want to use cosecant inverse of x equals sine inverse of 1 over x, so it can be in terms of sine. So notice how they gave us -2 radical 3 over 3. We're going to plug that in for x into our inverse trig reciprocal identity. This will flip. If you've done this enough, you'll know that this will flip to negative radical 3 over 2. However, I did show that on this page in case anyone was interested. So ultimately, we're interested in sine inverse of negative radical 3 over 2. But we know that sine is just the y value, so we need to figure out on the unit circle where y is equal to negative radical 3 over 2. And again, if you know your unit circle well enough, you'll know it's at 4 pi over 3 and 5 pi over 3. Your y value is equal to negative square root of 3 over 2. However, we're only interested in the fourth quadrant where that's true, namely between 270 and 360, or 3 pi over 2. And 2 pi. Now, since it said between 270 and 360, we'll think of this in terms of degrees. So we're really interested at this degree, which is going to be 300. Okay? So, at 300 degrees, the y value is negative square root of 3 over 2. And that tells us what? That's the same as our original question of cosecant inverse of -2 radical 3 over 3 must be equal to 300 degrees. Remember, your answer for an inverse trig function is an angle. All right, so hopping back here, that angle is 300 degrees, and since we were trying to figure out cosecant inverse of -2 radical 3 over 3, that's going to be our answer. 300 degrees, and that's going to be in between the interval they asked for, which is 270 and 360. All right, let's do cotangent inverse of radical 3 over 3. This interval is from pi to 2 pi. So, how can we figure this out? We're going to use the inverse trig reciprocal identity to convert to sine, cosine, or tangent. We want to convert it to tangent since that's the identity we learned. So we're going to plug in square root of 3 over 3 into this formula. It's going to be 1 over square root of 3 over 3. Again, if you've done this enough, you know that will just convert to square root of 3. So ultimately, cotangent inverse of square root of 3 over 3 is exactly the same as tan inverse of square root of 3. Going back to our tangent unit circle, this is why it's important. If you know this, you'll quickly be able to recognize that at 60 degrees, tangent is square root of 3, and also at 240, again in the first and third quadrant. Now, what are those in terms of radians? Again, you need to know unit circle in terms of radians. This would be pi over 3 and 4 pi over 3. How do you know if your answer is supposed to be in degrees or radians? It will be based on this interval they gave you. So it needs to be in radians. So we're asking between pi and 2 pi. So between pi and 2 pi is going to be down here in the second and third quadrant. So technically, we're just worried about that angle. Going back to our unit circle and converting it to radians, that would be 4 pi over 3. So at 4 pi over 3, we know that tangent is square root of 3, which means cotangent would be square root of 3 over 3, and that answers our question. So going back to our final answer here, this is our point on the unit circle where tangent equals square root of 3, which is 4 pi over 3. Since tangent equals square root of 3, cotangent must be equal to square root of 3 over 3, so cotangent inverse of square root of 3 over 3 is equal to 4 pi over 3, which lies between the interval pi and 2 pi. So that was a lot. We've figured out cotangent inverse of square root of 3 over 3 by realizing it was the same as tangent inverse of 3. We had to know our tangent unit circle and know that that was square root of 3 at 4 pi over 3, so we had to know in terms of radians, which we have right here. Okay, and then from there, we figured out, okay, well, if tangent equals square root of 3 at 4 pi over 3, then cotangent of square root of 3 over 3 must be equal. Cotangent inverse of square root of 3 over 3 must be true at 4 pi over 3. Again, the answer is an angle when you're talking about inverse trig functions. The input is a ratio. That's it for inverse trig ratios of standard angles. In the next lesson, we will look at answering in terms of an angle that might be beyond 0 and 2 pi or 0 and 3/16.